Hello everyone, my name is Ivan, and in this screencast I'm going to present the results of my 5LIC0 course project. My assignment was to develop a guide of how to set up an experimental LoRaWAN network with different sensors and gateways. The deployment in this project is based on the Things network. It's an open community LoRaWAN network server that is extremely easy to set up and use with a wide range of gateways and devices. In this video, I will walk you through creating a TTN account, configuring a gateway from a STM32 Nucleo development pack and adding it to the Things network, and configuring and registering an STM32 based Discovery Kit board as an end device. As a result, we will see an application that will show the packets from our device floating around in real time, as well as a gateway that receives uplinks and sends downlinks. For this purpose, I have set up a GitHub repository that you see on your screen, which has a detailed step-by-step instruction, and it can be referred to standalone. Basically, this screencast is a subset of what is in that repository manual. The repository contains information about more end devices and more gateways, and it can be extended. All the links and resources that I'm going to refer to during this screencast are present in the repository menu. So let's start, to begin with we need the Things network account. I assume you have that, so with that you would need to navigate to the console and you will see your dashboard. So the first thing that we need to do, I guess, we will start with the gateway. So the gateway we will be using is the STM32 based Nucleo development board that comes with a LoRa concentrator shield that makes it act like a gateway. So the shield communicates with the board using the AT commands or haze commands, but we'll come to that later. So first, let's create a gateway instance in the Things console. So let's go to the gateways and click Add Gateway. So here, there's a lot of fields to fill in. The one that we can fill in right now is the gateway ID, which is basically any string. So let's say TV gateway test. And let's take a note of the gateway server address. So this gateway server is something that the gateway communicates with. So it sends the packets that it receives from the end devices to the network server using this address. We need the gateway EUI, which is a unique identifier of the gateway by which it will be enumerated in the network server, but we don't have that yet. We can get it from the device itself. So let's hook that up, and so as I said, the gateway consists of the Nucleo board and the shield. The shield is powered separately by a 5 volt supply. So let's hook that up first. And let's hook up the serial communication and power of the Nucleo board. So as I said, the shield communicates with the board using the AT commands, and we need to get the gateway information from the shield. So what we are going to do is to launch a serial monitor. In my case it will be Minicom. I will set it up quickly. So let's see, what is the device that my gateway was enumerated to? USB modem. Okay. The baud rate is 115/200. Okay, and let's go. So now if we reset the gateway, we will see so we see the information and the configuration that it currently has. So we have to take note of a few things. First, we see the LoRaWAN server address. Currently it's set up for another network server, but we wanted to talk to the Things network, so we need to reconfigure that and have a note of an AT command that does that. It's also contained in the repository. So we just copy that, paste that. So we're passing this to the Nucleo board, and it communicates this command to the shield. So paste that. Okay, so if we reset this again, we can see that the LoRaWAN server now is set to the Things network. Now we need to go back to the console, but before that we need the gateway EUI. In the configuration of this gateway, it's called the gateway ID for some reason, but don't get confused. This is the gateway EUI that we need. So let's copy that, save it in some note. Let's get back to the console. Yep. So we paste this gateway EUI that we got from the gateway in the configuration, and basically, oh no, we have to select the frequency plan. So the recommended frequency plan for Europe is spreading, this is the European frequency band with spreading factor 9, which is the average between the smallest spreading factor 7 and the highest 12. So 9 is recommended as an average, but for testing purposes it can be set to any other. For now we'll keep it the recommended value. And that's it for configuring and setting it up. This is enough. So now we have created it. So the instance of this gateway now is in a network server, but as we see, the gateway is not connected to the internet at this point. We just configured it. So at my desk I don't have the Ethernet connection, so I will go and hook it up to my internet, to my network switch. The thing is that also the network you're connecting it to has to have a DHCP server to be able to give the gateway the address. Normally that's not a problem if the network does not have a DHCP server. There is also an AT command to set the IP address, the static IP address for the gateway, but this is covered in the manual. So I will go and quickly hook it up. So now that I've connected my gateway to the power and to the internet, what we expect to see is some action. So we already see in the console that there is, we connected the gateway, and we already see that it is receiving some uplinks from some devices. I have no idea which devices there are, because I have plenty of at home, but there are also devices around my area, so the gateway can pick up any of these. Alright, we have a gateway, that's good. So next, let's go and set up an application, because the application is an entity that will contain the devices that we add to. So let's add an application. This is pretty simple. We just give the application ID, so let's say TUE test, and create it. Oh, it is already taken. Yikes. Okay, TUE5LIC0 test. Okay, yeah. So now we have an empty application instance to which we can add devices, which brings us to the next point in this screencast, which is the end device. So the end device that we have here is also an STM32 based development board discovery kit that has an SoC Cortex M0 core, if I'm not mistaken, and a LoRa transceiver as a system on chip. So let's hook that up. So for now we just leave it. We'll go to the firmware later. We will also first create the device instance in the console. So here we go to manually and we start configuring. So we select the frequency plan, same as the gateway. LoRaWAN version, so this is this is not the latest one. This firmware and this device does not implement the latest standard of LoRaWAN. Regional, so we select MAC 104. Regional parameters 103 revision A. Okay, that will work. So here are the EUIs of the device and the application key of the device. So normally if the device is a production consumer device, these are hard-coded in the device and they're unique to every of them, and you claim it by getting this information the same as we did from the gateway. But since we have a development board, we have access to actually configuring this. So we can generate a device EUI, we can fill the join EUI with zeros, and generate the application key. Simple as that. But to continue further, at this point I would actually copy them to our node. So this is the dev EUI, app EUI, app key. So app EUI or join EUI. So to get the terminology, you can refer to the documentation. Oops. To the documentation of the LoRaWAN standard and documentation of the things network, because they also cover some points. So at this point we have our keys, and we just add the device instance to the application. So it's just sitting there now. We have the application and the device set up, but we don't have the device that actually has these keys, which brings us to the next point, making a firmware for our board. So there are two options. The choice, actually the general choice, is to run the mbedOS operating system from ARM, a real-time operating system, because it's really easy to work with, configure, and you will see in a minute. So there are two options to do so. First we'll go with the first one. So we have this thing called the mbed online compiler, which is essentially an online compiler. So let's go to, yeah, we can actually just Google that, mbed online compiler, which brings us to the mbed portal. We need to log in. So we're at the screen and we have the compiler button here. So we just go there. So this is a complete online IDE with everything that you might need to work with various devices, not only this board. So we are now at this home screen. Let's import a project. There is already an mbedOS LoRaWAN example that can be compiled for this target. So we'll just search for it. Just do LoRaWAN. And we see this project, which is authored by Team mbedOS examples. This is the one we need. We double click it. Yeah, I already have an instance of that, so let's just do one. We import it to our ID. Takes a while. Okay, so now we are inside our project. It already knows that the target we are using is our discovery board. It's actually, if it's not configured for you, you go there, you add board, and you search for this one and add it, and the compiler will know that this is the target you're compiling for. So now we need to set up this application, the firmware, so that the keys that we generated in the console are actually in the device. This configuration is stored in the embedapp.json file. So here we can see all the three keys and EUIs that we need. So let's just fill them in with the values that we have. In the console we can bring it to this format and just simply, oh, okay. It's late in the night. Okay, so it's the device EUI, we paste here. App EUI or join EUI is filled with zeros, as we remember, and we take the application key and paste it here. Well, that's pretty much it. So what the application, the default example application does is it has a dummy sensor and because this board does not have onboard sensors, so it has dummy sensor, which is basically a class that just sends some messages, and we have an event loop that just tries to join the LoRaWAN network first, and as soon as it does, it sends uplink messages with dummy data. This is essentially what it does. So yeah, we have it now. We have the keys. Let's compile. It will also take some time. So as an output of this online compilation, we will have a binary file, a binary firmware file. And the advantage of this board is that you can flash it with just putting the binary in the USB device that you can see on your machine when you connect this board. So we will see this in a minute. So actually we can already go, and we see this is a disk device that got enumerated when we connected the board. So this is just the USB device of the board. Actually, if you open that also and you follow this mbed.htm, it will bring you directly to the online compiler with something already pre-configured, but I'm not sure about that. Okay, linking. Alright, so we just have automatic download of our firmware, and yeah, we just put it there. Oh no, wait, first I forgot that we also need to set up the serial monitor. So let's do that, because we want to see what is happening on the device. So again, I go to Minicom, and this time my device, it actually has the same file descriptor, USB modem 14443. Okay. Yeah, so the device is here. We see there is some firmware there, but it does not contain the keys that we need. So let us flash the device, right? Yes. So here we have our USB device. We've put the binary file here. We can see that the board is blinking. It means that the firmware is being sent to the memory of the device, and it's done. So now let's look at the serial monitor. And we can actually already see that after the connection attempt, it has connected and it is sending something, as it says, right? So let's go back to the console and see whether it's true. And it is true. So at the page of our device, we can see the messages that it is sending, the uplinks. If we go to the application, we can see all the messages that are passing through application. So if we add more devices to this application, we will see all the messages from all these devices here. And we can go back to the gateway and maybe even see if we see our yeah, it is hard to identify whether this gateway is picking them up or not, because there are other gateways around here. But we can see that the device is actually online. Whoops. Yes, the device is online. So it is very easy to make a firmware for this board with a LoRaWAN example, even if you don't have any toolchain, any ID on your machine. There's also another way to work with this firmware that provides a little bit more versatility, I would say. So the repository that is on GitHub contains the mbedOS example LoRaWAN directory, which is actually a copy, but I think it is more up to date of the same example that we just used in the Embed Online compiler. The benefit of this is that you have this right in the GitHub repository, and you can modify the, for example, main event loop. You can add other things like buttons, sensors, whatever you like, and it will be on your local machine. So I will show you how to work with that. So we go to this project that is in the repository, and we open the code editor. The manual, the README in GitHub, describes how to set up a local toolchain to be able to cross-compile for this device on your machine. So I will not cover that. I will just explain how to compile the firmware from your local machine. So when we open the project, we actually see the same structure and the same files as we saw in the online compiler, including the embed app.json config that has the device EUI, application EUI, and application key. So what do we do now? We actually do exactly the same as we did before. We go, we copy the device EUI, we paste it to our file, we copy the application key, and yeah, so again, you can configure something that it is all here, and then assuming that you already have the toolchain installed, we go here. So this project has the mbedOS.lib file, which actually pulls the mbedOS, the whole operating system source code, and then compiles it all together into a firmware. So with the toolchain, we first do embed tools deploy, and it will pull the mbedOS from GitHub if everything goes right. Yeah. So it's pulling the latest master of mbedOS. The device is still working. So it does indeed just send some dummy values. My computer is suffering a little bit because I'm recording all this with two cameras and the screencast. It takes some power, definitely, but hopefully it will not take too long. Okay, so now that we have pulled the mbedOS source files, we have all the files that are necessary to compile the full firmware on our machine. Before compiling, we need to find out what is the target name of our device. So it can be any other device actually connected to your machine that supports mbedOS. So to enumerate it, we will do embed tools detect, and we see all the information about our device, which we already saw the serial port. So the board name and the target name is actually the same in this case, which makes it nice. So now we need to compile. I actually have done this already. So we specify the target name with the key M and the toolchain with the key T. I'm not going to go into the detail about the toolchain. The installation is described in the repository. So we're going to start a compilation. And what we expect is actually the same binary as we have received with the Embed Online compiler, because in this case we use the same project and we have not added any extra code or whatsoever. We have also just configured the keys, but potentially yeah, you can do all kinds of stuff. If you go to the main CPP file, yeah, you can look into the code and see what can be done. So let's see. The compilation has started. So the embed toolchain since last year is using CMake as a build system, which yeah, everyone has their opinions about that, but I mean, if it works, it works. Okay, so now that we see that our compilation has completed, we have a few output files, including the binary file that we are able to flash to the device. We see the path that it was put in. So what we want to do now is to flash it as well. And what do we expect is that the device is still running the firmware that we produced with the mbed online compiler, and we saw before that it is successfully connected, it's still sending the packets. So what we expect is that exact same behavior will happen, but after the flashing. So we will verify that the new firmware actually works as well. So let's do that. Let's again open our the USB of our device, and we see the binary here in the path that was there in the terminal. So we put it there. We see that the device is flashing again. So we can look back to the serial monitor, and we see that okay, it actually started the firmware and it tries to join, tries to connect to our network. Let's see if it works. Okay, takes some time, but yeah, the connection is successful. So we connected to the network server and we continue sending the messages with the new firmware that we built on our local machine with the ARM embed toolchain. Let's see. Yeah, so the console also shows that we have just accepted the join request and we already received some messages from this device. So yeah, that's pretty much everything that I wanted to show in the screencast. I hope it was helpful. I hope it provided a great insight on how to make a quick start with LoRaWAN, with the Things network, and some development boards, development gateways. So this all is not limited to these devices. Again, as I said, the repository contains a few more gateways, but there are many more others that I did not cover. I hope, again, as I said, this will provide a head start to anyone who is watching this. Thank you very much.